Everyone, myself Arun Kumar from SNS College of Technology in the Department of EC. In this video, we are going to see about step response analysis in time response analysis. So these are all the slides we are going to see in this video. Understanding the basic elements. While considering the step response analysis, we need to consider the elements like omega n and delta. So because we need to consider all those values based on the damping frequency, because omega n only define the corresponding frequency of the signal so that it will be indicated to the first order or second order system. So it is having some confusion between the first order and second order system. Let me see how these system will be indicated successfully. So like that W omega n and del. So omega n is an undamped natural frequency. It is used for first order as well as the second order system based on the number of oscillations generated in the circuits. And next one is damping ratio. It is the measurement of the degree of resistance to change in the system output. So it is the clear defined about the actual output and the original output. So this difference between these two output has been done with the help of this damping ratio, and it is followed by the transfer function C of S divided by R of S. The final value of the equation is G of S divided by 1 plus G of S. So that the equation have to written it as omega n as omega n square divided by s square plus 2 del omega n s plus omega n square. So here the omega n is a damping natural frequency and del is a damping ratio. So based on this, we need to consider and calculate the values of the omega n as well as the del values. So the damping ratio. So the damping ratio is nothing but actual value and the original value. So the difference between the actual and original value is the actual is coming as the output of the system, and original input has to be input has been given to the system. So based on these two difference, we need to calculate the corresponding actual damping systems. So the damping conditions may be differ based on the different scenarios. So here there are four type of damping systems are used for calculating the damping ratio. So first one is undamped system, del equal to 0, and underdamped system is 0 less than del less than 1, and critical damp means del equal to 1, and overdamped means del greater than 1. So see, these are all the conditions based on the classic equation by s square plus 2 del omega n s plus omega n. Suppose if you are considering as undamped system means we need to put a del value as 0 so that the final equation has to be generated based on this condition. Next one is critical damp condition. So here the value is del equal to 1, so that we need to consider del equal to 1 for this equation. So the final answer based on this generation of the transfer function of the systems. So while considering the underdamped system and critical damped system and overdamped system, the corresponding value of the del is considered and it will be communicated to the classic equation. Suppose the undamped system and critical damped system is having some values, so that we need to suppose we need to give these values to the classic equation so that we get the informations. Suppose if you are considering underdamped system or overdamped system, it doesn't have any values because 0 less than del less than 1, so that it will be comes under 0 to 1. So we can't able to predict the values. At the same time, the overdamped also, because it is del equal to greater than 1, so that we need to consider above the value of 1. So these two systems will not be exactly define the corresponding damping ratio of the system, so that we may consider undamped system as well as the critical damped system because it is having the actual values. FAT control systems, based on the input and output conditions, the values has to be plotted based on the different damping conditions, undamped, underdamped, critical damped and overdamped conditions. and developing solutions. Suppose if the system is having a overdamp means daily greater than 1, so it will be the poles and roots has been occurred after 1 only, so that it will indicate as a minus A and minus B. And for underdamped system is nothing but 0 less than 1, so it must be kept under this 1 value, because 0 to 1, so 0 to 1, so that it may be appear these two values. And next one is undamped system means this value exactly 0, so it will be comes under 0 j omega plus or minus, and it will be considered 0. And next one is critical damp. Critical damp means del equal to 1, exactly it will be appear as a 1, so that it will be marked as a minus a. Mind mapping. So these are the mind mapping systems for this step response analysis activity. Here we are given about thing pass. The thing task is analyze how the steady state behavior of a control system is achieved by the interaction of the reference input and error signal, controller type, and plant characteristics in industrial applications. Take a 5 minutes to think individually, then discuss your observation with your partner and give your answers. So let us consider type 0, type 1, type 2 systems, because these only define the corresponding damping ratio of the systems. Assessment. The steady state error of the feedback control system mainly depends on transient response, controller hardware, system type, sensor bandwidth. The answer is C, because it is having a which type of operations. And next one is which element of a control system directly influences the steady state accuracy through the interaction. Option A sensor, option B actuator, C plant, and D controller. So the answer is D controller, because the controller only define the exact output of the systems. So these two has been taken as the reference for this video. Thank you.